Hi, my name is Jocelyn Disla, and I will be presenting this product prediction analysis project. This system will be called Structured Advice for its helpful suggestions to marketing teams and production of its ability to predict sales and overall product favorability. The system will gather information based on consumer feedback and previous sales to understand which products will be bought and desired most. Businesses typically have the issue of adding new products to their inventory that may risk more costs than it does in profits. The goal is to continuously maximize profits, minimize the amount of time products are on the shelf waiting to be bought, and acquire new customers from the increase in consumer traffic. Distinguishing good from bad predictive advice can lead to better decision-making in a company. This dataset is an Amazon Fashion Sales CSV file, retrieved from data.world. The original dataset has 10,000 rows with 17 features. It describes the product, the manufacturer, the price, the rated review, the number of reviews, the product category, and other additional product information that was later disregarded solely for this project. In the process of cleaning the data, the excess wordage such as quote-unquote out of 5 stars in the rating feature was removed so that its numerical value is all that would be used. This process was also used in the price feature since the price was in euros and the euro symbol was removed. The string values in the product name category and maker were transformed into distinct numerical values that were synced with their string value. The only feature that was left untouched was the number of reviews a product held. Once all the non-values were removed from the dataset, the target variable was set as the review rating, which was a float ranging from 0 to 5. 0 being the least liked and 5 being highly favorable. The target variable is the average rating, since that's what this project is focusing on, the product's appeal to the consumer. While preparing the data, I cleaned it as discussed in the previous slide and split it into a training and test set. The training set was 75% of the data and the remaining 25% was used for the test set. A random forest model was used to forecast the product's performance and to be able to find out the relationship significance between features and the target variable. The score of 0.538 for the training set using an out-of-bag estimate signifies the number of correctly predicted rolls. The OOB score was not impressive and demonstrated a weak prediction of the results with a 3% rate above random guessing. The model was tested with the testing set, and I then retrieved the accuracy score, confusion matrix, and feature importances with the forest of trees. The calculated accuracy of this model also provided a similarly low score of 0.529. This demonstrated the model did not learn anything useful with the features compared to the target variable. A confusion matrix was plotted with a calculated hypothetical best model. The matrix demonstrated incongruence that supported the model's lack of learning. The feature importance displayed the number of reviews being the most impactful feature to the product rating, and the product name as the second most important feature. The least important feature was the category the product was in, meaning customers are not looking for a category first when deciding what product to buy. Lastly, the plotted trees emphasized the target variable's non-binary values since the ratings were floats. There were many trees that made the plot look much more complex and harder to understand. The random forest model performed poorly with the Amazon dataset, performing only slightly better than a random guess. Customers are focusing more on the product and reviewing the ratings others have left before deciding to buy. This suggests that customers are not looking through a category to find their desired items, but instead looking up the name specifically, then gathering information from previous buyers to decipher if buying the item would be a good idea or not. This information creates a theory that the more ratings an item has, the more likely it will be continued to be sought after. According to the Luke Burgess article regarding mimetic desires, seeing someone else have an item or enjoying an item makes it more desirable to the person observing. This supports the model's features importance calculation of number of ratings. Since more people are buying this item, there must be something amazing about it that has them buying it and writing reviews on it. This model would suggest that refocusing on retrieving serious public feedback on products can potentially be more alluring than traditional sales tactics, almost like another form of word-of-mouth advertising. Applying another model to this system would create a more efficient and trustworthy accuracy that companies would be able to make important profitable decisions off of. In the future, applying this model to the product ratings would require more information regarding the review's quality and overall message, such as whether the amount of wording placed in the review would have a bigger impact on its effect on passing viewers. Implementing this model for insightful findings can also bring new ideas to the table for marketing teams while opening new doors to organized data on reviews. Applying a tokenizer to the reviews so that the machine can evaluate the messages would be very beneficial moving forward. Some ethical implications stem from gathering information on highly reviewed items to influence a consumer to buy something that they haven't consciously thought of or chosen. This intention would be like preying on consumers' psychology and mental vulnerabilities, which can potentially lead to issues ethically. Based on the data itself, Amazon products, reviews, descriptions, and other information are public and will not create any ethical issues. Challenges in the future that may come around would be working with a tokenizer to evaluate the descriptions so that the outcome provides insights on recommending similar products. Another challenge would be to decide which feature to focus on so the process is not as time-consuming while also still maintaining important features to maximize insights from the models applied. Here are the references used in this project to help back up my claims. Thank you so much for staying tuned throughout the entire presentation.